of people, and I myself, often go back and forth. So I have a few students who are taking AI, and it's it's less in number, obviously, until you also understand the popularity concerns. But yeah, it is challenging to be really clear about. Even though IB tries, there are still people who would disagree with whatever they say in their guides. So our aim is to have a discussion about what it means to actually understand and teach IB mathematics for the DP. So I'll share my screen. I hope everyone can see the screen now. All right.
Yes, Anish.
Okay. So yes, and I'm still waiting to know, like, if all of us are math teachers, or we also have people who are just interested in knowing about IB mathematics. So now we'll be talking about. So this is the third session, as I mentioned. It talks about IB, AA, and AI mathematics. So for those who may not know the distinction, it's basically a recent thing that IB has done in 2021. So starting 2021 examinations, which is 2019 being the first year that it was taught, they have revised their mathematics coursework for the DP, which is the high school level curriculum, into. So they have kind of revisited that and reinterpreted their entire philosophy into these four variants. So prior to this, they had mathematical studies, they had IB mathematics, SL, HL, and further mathematics. But so those four categories were kind of murky, and some people might argue that they haven't quite, really changed that. They've just renamed them and rebranded them as these four topics here. But then that's highly arguable. So yes, the IB mathematics, the mathematical studies, was supposed to be a coursework for someone who's not motivated towards any of the mathematical, uh, courses, or has no mathematical interest, but must understand the basics of mathematics that are required for everyday life. So that was their aim prior to this. And the SL was for people who might use mathematics, or their careers might require some extent of sophisticated mathematics. And the HL was obviously meant for advanced mathematics students, and people from students who want to take hard sciences or engineering. So that was the case before. Now we have these four, and they're still branded under two titles, and that, I think, is the cause of distress amongst most teachers that I meet, at least, because people who have been teaching IB mathematics for many years now, they find it difficult to accept or to adapt to this strategy. But then I've also seen more younger teachers being more positive about this. So again, this has received mixed reviews from the IB teaching community. So what we have here is applications and interpretation, and analysis and approaches. These are the two major, the two bifurcations that they've made. And within that, they have HL and SL, of course. So that actually means that an IB student must choose from four options when it comes to what mathematics course they want to take. And telling them, being able to assist them with these things, is a very challenging thing. So there are lots of concerns, and what we hope to do today is to go into the practical considerations that we must take, that we must think about, and also some very technical things about how the evaluation actually differs. Like I said, if any of us have any views that they already want to discuss, or maybe they would expect that we should talk about those things, do put them in the chat so that we can take them up. But the way this session would go is basically we will talk a bit about each of these distinct variants, and our aim is to understand how we can help students pick the right course for them. So now, according to the IB, this is what they are saying. So basically, they're like, if someone wants to take mathematics just for the sake of it, so it's similar to the mathematical studies or the math studies topic. That's application and interpretation SL. That's very basic mathematics, not advanced, no advanced concepts as such. So basically, the everyday math that you just have to know to survive in the world, basically. So that's how they want to put it. And then we have applications and interpretations HL. Now, this is according to them for students who are strong at math, but do not plan on studying math-based courses. So this is very specific, and this can be the point of argument there. So a lot of teachers think that this is not true. And part of this discussion will be to ascertain whether this is the case. So if you do not plan, immediately you can see that a problem with that is, what does it even mean that you do not plan on taking a course, or you don't plan on studying something that is math-based? So today it's very difficult to tell what you'll end up doing. And so how can I be really sure, unless I'm absolutely doing, even if I'm doing visual arts, or I'm just planning to be a musician, how can I be sure that I'm absolutely never going to do anything that is not that is math-based? So I, in fact, had an old student who, like, I think I mentioned this last time, where she was taking math and music, both HLs, and her eyes were very, very complicated. So they integrated these areas, and so yeah, it's very difficult to tell. Now, so which is also why we need to understand in more detail what these courses really are about and how they have been designed. So that's the AI topics, or the variants. We have then the analysis and approach. This is the most comfortable variant of the course so far, because to most IB teachers who have been teaching mathematics, this is very familiar. So what they have been doing, they just keep on doing with some minor changes. So this is also why this is a popular choice, even like in the past 3 years at least. AHL remains the most popular choice for advanced mathematics students and students who want to take science-based, who want to pursue science-based careers. And AASL is the next best choice. So basically, going from right to left, we have the variants in their order of preference. Basically, so the one on the right is the most preferred by most schools, universities, and teachers. And as you go towards the left, it becomes less and less desirable. So that is generally how things are. And there's a lot of debate, even today, about if that is true and if that is supposed to be the case. So one thing that obviously comes up again is we must read the guide to understand if that's what's the real deal there. And the guides also can be very difficult to interpret in terms of what it is that the student must choose. So of course, at the end of the day, it comes down to the interpretation or the understanding that an individual has. IB, of course, is a very student-oriented program, so it kind of expects the student to take a lot of charge and be responsible for what they want to do. They also want students to plan ahead in terms of what they would want to do after their DP program is completed. So these are, again, very practical considerations that do need to be addressed here, because if I'm going to take a particular variant of these math courses, then I better have a plan about what I want to do next. Because, either way, if I choose the wrong variant, then I might have to retake this, or maybe reappear for another course. And if I take something that is unnecessary for me, or as a student, I feel something that is not necessary, then I'm just putting myself through a lot of stress that is not required. So in either cases, it's very important to know what exactly these courses are about, and which one will suit a particular student the best. So to make things slightly more clearer, it helps to understand how exactly the topics, what are the topics that they teach, and what are the things that actually get discussed. So to talk briefly about that, what I would like to do is talk. So, like I said, it's very vast. Both the courseworks are extremely elaborate, and they have lots of things to go and look for. So I encourage all the teachers here who haven't gone through both the courseworks to actually go and read both of them, because I think for most people who have advanced degrees in mathematics, it becomes very clear what IB is trying to do. And so if you read both of them, you can then actually tap into IB's philosophy. So you can understand why IB is trying to do this. And the subject breakdown is one of the ways we can understand it. Of course, this is, again, just the tip of the iceberg. So we definitely want to look at specific topics and how they are dealt with. And we'll be taking an example of that soon. But more generally speaking, when we look at how the topics have been divided, we realize that the breakdown suggests that certain concepts or certain topics are given more preference in applications versus analysis. So the second and the fourth bar charts here are about the applications HL and the analysis HL. And we can see that analysis, so the AAHL, focuses way more on calculus, and statistics is kind of downplayed. So we don't really do that much statistics. And again, geometry and trigonometry, especially trigonometry, is very high, like it's elaborate in AAHL, and it's not that elaborate in applications. Again, it is, but and we'll talk about that. But first, I think we must talk about the calculus requirements. So the reason we have this stark difference between the amount of calculus that the AAHL student and the AIHL student must take is because calculus has to do with a lot of modeling. So and that this can be abstract modeling about situations that don't necessarily have an immediate application, but it still is an important part of the overall scientific enterprise. So that is to say, if a student is more inclined to go towards theoretical sciences or more fundamental sciences, so that is physics and chemistry, where a lot of models are involved, then they're very likely to use calculus-based models to discuss and to describe what they're working with, because those systems are inherently abstract. So we cannot look at an electron like, empirically. We can just detect them as spots or lights. But their models, what they are really are mathematical models, and they depend on the change of different quantities, which is ultimately calculus. So the emphasis on calculus there shows how the AA wants to focus more on the modeling and conceptual aspects of mathematics than the application parts of it. As opposed to that, an emphasis on statistics and probability shows a more obviously practical, a pragmatic take, a pragmatic use of mathematics, because so AIHL students would talk a lot about matrices that AAHL students don't. And they would also talk about statistics in a more practical, like they would study modeling through statistics and not calculus, for instance. So this is something where we want to think more about, because it's not the case that statistical models are not used in the hard sciences. So physics, for example, does explicitly use statistical modeling as well. But more prominently, biology, ecology, and all these, even chemistry to some extent, economics. Uh, so these are the sciences that use statistical modeling more than physics or engineering sciences. So this means that applications HL is kind of more suitable for students who are studying biology, chemistry, economics, and these kind of the non-physical or non-abstract sciences, where the topic of conversation is pretty evident, it's tangible, you can speak about it. So maybe it's the cells you're speaking about, or the population of rabbits, or human populations, and so on. So where the modeling is more statistical, it helps to learn how statistical models really are made and how they're applied to real life situations. So in that sense, AI is more practical oriented and more real life based. But again, we have to understand the difference in the modeling strategies there. And for a student, so what this means for a student is that they have to decide what kind of science they are they really like and want to pursue. Now, that can be challenging at this level. So a part of the discussion that we must have with students is also whether or not they're really happy with the subject choices that they've made, if they feel very confident about their choices, and whether they really want to pursue it. So, I mean, of course, they might change their minds later, but at least during the time that they are appearing for their IB course and they're studying for their IB exams, they should have a clear mind about what it is that they really want to study there. Now, a slight focus on trigonometry. So right now I'm just speaking about the HL variants because you'll see that for SL, so yeah, we'll come to SL in a moment. So trigonometry, again, so there's not a lot of difference in how trigonometry is taught in the two courses, but one of the ways in which it differs is, again, trigonometry is used for a lot of mathematical abstraction. So for instance, the use of complex numbers. Numbers comes as a part of the foundational theory of numbers. And so if you think more in terms of abstract mathematics and how the mathematics was done in the old days, you have this overarching theory that somehow everything comes from the same idea. And excuse me. So there's this larger abstract notion of mathematics that comes from the Platonic understanding. So in that view, when you study mathematics, you have things like proofs that are more important because they follow a certain axiomatic system. More logical manipulation of ideas also becomes more important because you're working under this umbrella of abstract mathematics. So there, trigonometry is treated differently because it's a part of a larger system of functions, and somehow you can use that as manipulation tools for conceptual analysis. As opposed to that, the AIHL will mostly focus on trigonometry as a very objective tool for just working with things. So if you want to say talk about angles that you want to construct something, obviously angles are important, and the trigonometric analysis that you want to do of that particular situation is very limited to that practical application that you have. So there again, the way it's taught changes because they are really focusing on whether or not a student wants to go very deep into these concepts, or whether they just want to make use of it. So that is something that's also worth mentioning about the IB, the differences between them. As for number and algebra, so algebra again becomes more important. And what we mean here is, so that is again another significant thing. And we can see that algebra is more heightened in AAHL as compared to AIHL. And that's again because IB is focusing on this more foundational, fundamental ideas in mathematics that are somehow, universal and So again, it becomes very abstract and philosophical, because then you have set theory to talk about, you have binomial expansions to talk about, and what those binomial expansions mean in the larger scheme of functions. All of those, more abstract connections are emphasized, which is why AAHL becomes then a very heavy coursework to go through, actually. Not to mention the proofs. So um, there are very small or next to no proofs in AIHL, but proofs are very elaborately dealt with in AAHL. And that's again because it wants students to be able to deal with those abstract concepts. And that's again because under the traditional view of mathematics, it's assumed that you cannot create or do new mathematics unless you have those foundational things in place. So that's something that we also want to remember here. The last thing we'll talk about in the subject breakdown is this unusual, the breakdown of the applications SL. And you notice that even in the applications SL, they kind of keep the statistics and the functions to the maximums of other things. So number theory, trigonometry, and calculus, these are kept to a minimum, which is to say that any abstract idea, so these are all the abstract ideas. Trigonometry is an abstract, so it's all, trigonometry, number theory, abstract algebra, all these ideas are again not required. And so the only focus of applications SL is functions, which is to understand the relationship between quantities, to be able to do some algebra and understand how we connect different ideas mathematically. And of course, statistical modeling of things, which tells us basically how to predict things and be able to interpret common theories like evolution and stuff like that. So that is again a point, a very highlighted, an element that should be highlighted here. So when you look at this, it is then obvious that maybe what IB initially says about what these what these variants are supposed to do and who they are supposed to suit, it may not be very black and white. So you can't just say that AI is just for people who don't want to plan a career or don't plan a career in mathematics or something like that. It then becomes obvious that every student, depending on what they really like to do, they might want to choose from these four options as liberally, so weighing them equally, because it's possible that so generally, of course, the SL students don't want to take advanced degrees in mathematics or in the hard sciences. But so that distinction between the HL and SL is pretty evident. But other than that, it really depends on the student and their requirements. So that's something we really want to talk about. And I think, and we'll talk about that towards the end of the session. So I hope so far it's clear how the topics, what the coursework really is like, and what topics are treated in what way in the two variants, at least the HL variants. Right. So just to give you an example of what the difference in the approach means, so what we generally mean by a more practical approach versus a more conceptual or abstract approach. So to give you an example of that, we have a question. So I'm not sure if you all can read the content of the question, because usually one shouldn't put a lot of text on the slides, but there's no other way to do that here. So on the left-hand side, as you can see, you have an AA question, right? And the topics are similar. So these are both from vector algebra and vector analysis, where they talk about cross products and finding the volumes of shapes using vector analysis. And what we notice is that while the objectives are similar, so for instance, students are also asked to find the volume of the parallel of the shapes in both the cases, But first of all, uh, of course, AA is more elaborate about what they should be doing. But more important points of consideration here are that the AA question is immediately more abstract in its approach to this topic, just the idea of cross products. So it expects students to understand that cross products are not just a tool for manipulating a certain idea. So it's not just a mathematical tool that you can use for finding the volume of objects. Of course, that is the application. So AA also focuses on the application in that sense. But at the same time, it wants students to be aware of the idea that what we do with vectors is a part of a larger scheme of concepts. So vectors would, of course, come from scalars, and then we also have four-dimensional analysis, so tensor. So basically, if you want to study abstract mathematics, then you kind of realize that vectors are part of a larger family of quantities like tensors and scalars. So you have scalar fields, tensor fields, and so it's a more abstract idea, and we are just using that abstract idea here. And that's the approach for the AA. They want you to be aware of those ideas. So concepts like the rank of a matrix or the rank of a vector, or the determinant. So what does it mean for these values to be 0 and non-zero? These are more conceptually dealt with in AA than in AI. So of course, those ideas will still be mentioned in AI, but the students are not expected to go into the conceptual depth. As long as they can make use of them here, if they can find the area of the triangle, for instance, find the volume, they know how to manipulate and work with these ideas without having to bother too much about the concepts behind it. As opposed to that, if you look at the AA questions, it's almost impossible to solve or to answer some of the questions correctly unless you have an in-depth understanding of this topic. So the triple product. So it's again a very on the face of it itself, it's a very conceptual idea, and we need to establish. So we have to find the so-called triple product, which means we must first know what it is, and it's a concept. It's an abstract idea. So of course, we may still be able to show that the triple product can be used or it has some applications in the real world, but nevertheless, the concept remains abstract, and that abstraction is something that a student is expected to understand. So yeah, through this, and there are lots of other examples. So if you just look up the question papers for the two, and again, I understand if the teachers here are very worried about the content that is available. So it's just been 3 years. Like the first exams happened in 2021. And so we still don't have a lot of material to understand the distinction very clearly. But examples like these can make it clear what the IB is really going for. And in a way, it's also a good thing, because since it's a new change that they have brought about in the math curriculum, it allows teachers and tutors to also grow with that. So they might end up making some changes if they feel that certain topics are required in AI and maybe not required in AA. So if we kind of go with IB on that, and we try to understand their ideas behind how they want to teach these things, we might actually understand something more fundamental about how to teach mathematics, because IB is really struggling to do that, and I mean also excelling, of course, because it's one of the most compelling math curriculums that have been designed. So, but again, it also understands and acknowledges the problem of teaching certain ideas in mathematics. So even if we think that there is no need, like we only have AA students and I'm only comfortable teaching AA, even then as a teacher, I think one should be interested in learning more about what the AI is all about, and that will first of all help us understand the conceptual, the pedagogical differences that IB is trying to highlight with it. At the same time, of course, we are more informed and in a better position to tell our students what variant they must pick. So now that's a short analysis, like that's the extent to which we will have the technical discussion there. Because, and as I said, if we want to talk more about that, we can do that. But there's no end to that. You can take every topic and every question that is of the same topic and compare how IB treats it differently in the two courseworks. So, and that's something the teacher must do in order to understand the differences. So what we want to talk about now are the the practical considerations that we need to think about. So first of all, the academic goals of the students. So I mentioned this earlier. IB assumes that the students will be self-motivated. And I mean, while that may not always be the case, it still works under that assumption. So we do often have students who have no idea why they're doing this or where they would want to go after this. So that is one of the first challenges, because even if we understand the distinctions in the AI and the AA, we still need to ensure that the student fully accepts that and they're aware of what they're doing. So that can be challenging if the student is not motivated towards mathematics at all, or if they are, then they're not very sure about what they would do next, so in their life. So I mean, IB assumes that they should, so we should probably try to encourage that kind of thinking, but in the least, we need to tell them about these distinctions, and just so that whenever they take the decision, they know what they're really doing there. A second point there is, and this is something I included in this discussion because that might be relevant to many of the tutors here in Tutopiya, because we get students who are studying in different schools. So we're not a school, of course, and different schools have different policies about what subjects they want to allow in their school. So as a part of the IB organization, that a school can choose what subject they want to teach in their school. And to my knowledge, like most schools will just avoid taking AI. And that's because of the misunderstanding of what it is designed for. So yeah, we see a lot of AAHL students for that reason, and otherwise you see AASL, but you don't see so many AI, HL, or SL. So I only have, I think, a couple. So, and that's, again, because a lot of schools might just not provide that option. So even though IB has an option, the school may not. And so it is, even then, it is, as IB teachers, it is our duty to inform the students about what the curriculum actually has for them. So, and of course, they can decide for themselves whether they want to continue with what their school offers, or if they want to take this thing externally or something. But it's very important that we are able to tell students what the entire spectrum of IB mathematics is all about and how to navigate through that. So whether or not the school actually allows for all the four variants to be selected. So I think most of them do, but yeah, I know many schools that do not have this option of, oh yes, please.
Himanshu, I had a question. Suppose if a student wants to pursue some, some courses like maybe in finances or statistics or something economics. So in that case, which should be considered, maths, AA or AI? Like what they should take in school?
In economics?
Yeah, some like practical things like finances or maybe statistics. If they want to pursue it later on as a career, then what should be opted for in maths?
So if by finances and statistics we mean something of the actuarial sciences, so where accountancy and all those things, then it's obvious that we don't want the conceptual things there, right? So we don't have to think about the fundamental nature of things and how, mathematics, whether it pertains to reality or not. So all those discussions are pretty evident in AA, because you go into proofs, you go to the lens of, what does it even mean for the limit to go to infinity. So uh, if we can avoid those discussions, then we can only work with mathematics as a tool.
Mm.
So anybody who wants to do finance, they actually will be helped by AIHL, because they will study more modeling with statistics, which is required for finances. So all the things, like all the banking, models, and they're all just statistical models. And so the investments and stock markets, they also follow a statistical model. So being able to understand that will actually help them. And so someone who's more inclined towards finances and the actual sciences should take AIHL,
Okay, understood.
right? But then again, so while that is true, and it's good that you asked, but we also have to remember the third point. So another problem is that, so one problem is on the side of the student, where they understand like what they want, and whether they understand it or not. The other thing is whether the universities understand the distinction between these courses. So a lot of times, I have students who are taking AAHL even though they don't have anything to do with abstract mathematics. They don't even want to pursue physics or engineering. But it's just the fact that the university that they want to go into, even though they want to study biology like medicine, just because the university would not accept AIHL, they have to take AAHL. So, practically speaking, that's something a student must also think about. So, as tutors and teachers, we need to understand that universities do explicitly write these things in their policies. And when a student applies for their undergraduate degrees, there are strict criteria as to what kind of combinations are acceptable. So, every student wants to initially go to the top ranking universities. And while it is true that practically they might not ever use the stuff that they've studied in AAHL, the universities might nevertheless want them to study those things. So it's very, very important that we also tell students about this and help them navigate through that, if possible, of course, to depending on how much time we can devote to that. But these discussions and these considerations are very important in the beginning, before, the student makes the decision about what variant they want to choose. And this can also be done midway. So after the first year, also, it's possible that if the student is not at all happy, there are provisions that can allow them to change the subject. But then again, that depends from country to country, where it is allowed, where it is not. So knowing all these technical and practical aspects of the mathematics curriculum is very important. Now, especially that IB has given us these, for for like this entire thing to work with. So yeah, it does put some more burden on the maths teacher there, because I myself have had long discussions with other colleagues, and some also like my seniors who have been working in IB for many years, and it becomes evident that it is not very obvious how to make the decision, and it's a very case-to-case thing. So that's what we want to ultimately aim for, and hopefully, if we understand the student and their requirements correctly, and then we can decide which is the best strategy for them. But these are all the considerations that we need to take, so including the universities, because even if the student is happy with taking that course, and that's actually what they might use in their life later on, if the university does not accept it, then that's going to be a problem. So yeah, we should be able to speak to parents about these considerations, because if they choose a different math coursework for their child without realizing that, it might actually not help him get into a place that he wants to. So yeah, these are broadly the considerations that we want to keep in mind. And Yeah, the general idea is to like explore both these courseworks simultaneously. Like if I take up the same topic, like with the example I mentioned that. So even if I have like there are similar topics, of course, because they do things similar. There are very few topics that are unique to AI, and there are a few topics that are unique to AA. But the overlap is massive, and most of the time the difference there is the extent and the approach uh, towards these topics. So that's pretty much it. That's the discussion about, at least the basic discussion about the differences. We can have more discussion here now if there are any specific questions that we have. Otherwise, I think these Yoda memes kind of show roughly what the distinctions are. So do we have any questions or anybody has any comments or?
Team, if you have any questions about what we discussed throughout the IB training, please let us know. Okay. So we had a assessment after session 1 also, and similarly we have another assessment after this session. We'll be sharing the link of the assessment via mail as well. So I request you all please go ahead and solve this assessment so that we will also understand how much this training was helpful for you. And if you have any suggestions on how we can improve the trainings, please let us know. And yeah. Thank you so much, Himanshu. I really like the joke, the last one.
I mean, yeah, the IB, so the IBO, the Reddit, and all these online forums, those are actually very important for IB teachers as well because they keep us updated about what's going on. And you have all sorts of these memes out there, and they kind of do capture the idea sometimes really well.
Yeah. Actually, making memes require a lot of intelligence.
I mean,
So
if this is
you have to be quite relatable. Only then you can create a good meme.
so yeah, I would also appreciate about the forms, they're just so that we can revise those things for ourselves. Of course, like I said, this is just scratching the surface. So those forms are just meant to, first of all, give more feedback. So if there are any questions, I explicitly ask for that. And if we can make this an ongoing process where, we have a group of maybe tutors who want to discuss those things, I think that is also a good idea where we have some concerns. So like presentations like these are time bound and we cannot really go into the details. But if we have a more open platform where these can happen from time to time, I think that would be more beneficial for tutors.
Okay. Thank you so much, Himanshu, for such an amazing session. And thank you everyone for joining in. We'll let you know of all the future trainings as well. Thank you.
Thank you.